students. So the topic of today is salt. In the previous video we discussed about your acid and bases, what is pH, how to calculate pH, and how to use pH scale for identifying the strength of acid or base, what is the range of base, what are the range of acids, what is the point for pure water or neutral solution, that is 7. So all these things we discussed in the previous video. Now we are going to talk about salts because we have discussed about acid and bases. So today's topic is salt. Now how to define a salt? Very easy. For that you have to go back to the definition of acid and bases. See, when acid is dissolved in water, as you know, it liberates H positive ion, and if you dissociate base in if you dissolve base in water, it dissociates and gives out OH negative ion. So from these two ions we are going to get the definition of salt. How? Let us take an example of salt first. Then I will give you the definition. Then it will be easy for you to understand that definition. If I dissolve salt in water, what you will get is Na positive and you will get Cl negative. Now see, this positive ion is not H plus ion and the negative ion is not OH negative. Okay, so what does it tell? It tells that salt is a chemical species which when dissolved in water gives a positive ion other than H positive ion and a negative species other than OH negative ion. This is the simplest definition of salt. Salt are the chemical species which when dissociated, which when dissolved in water gives out or dissociate into a positive ion other than H positive ion and a negative ion other than OH negative ion. So in this way you can easily define a salt. Take the help of definition of acid and bases, but do not focus on single ion. Suppose you are only focusing on this part, then you will misunderstand that particular species. Why? Suppose I am only focusing that it should not be H positive. So that is the case of NaOH also. Na positive plus OH negative. So if I am only focusing on the first part and I am observing that H plus ion is not here, so I cannot call it as salt. I have to check the second part also, this one. Because if you go by first part only, definitely you will call NaOH as a salt if you are not checking the second condition. So according to second condition, negative ion should not be OH negative ion. So here negative ion is OH negative, it means this is not a salt, this is a base. So for checking a species whether it is salt or not, you have to check that positive ion should not be H positive and negative ion should not be OH negative. I hope it is clear. Now let us move on to the types. What are the types of salt? Now see the first type according to your syllabus. First type is acidic salt. I hope word is giving you some information about this salt. Acidic salt means which will be acidic in nature. How? See, these are formed when a basic radical replaces replaceable hydrogen ions of an acid. Partially. Remember the word partially. Suppose I am taking NaOH in a limited amount. In limited amount you have to take. So what will it do? It will replace only one hydrogen. NaHSO4 plus H2O. Now focus on the salt. The salt that you are getting is sodium bisulfate. So here you can see that H is there. That means if I dissolve it in water, I will get H positive ion. If I get H positive ion, it means it will show acidic property. This gives you the definition of acidic salt. Acidic salts are the salt which gives some property or shows some property of acid. Why? Because there is still a hydrogen present in their formula, NaHSO4. I hope it is clear. Acidic salt are the salt which will exhibit the property of acids. Next part, what are basic salts? Sorry, not basic salts. Second part, according to your syllabus, is normal salt. Now what is normal salt? Let us take the same equation NaOH. Now I am taking it in excess plus H2SO4. This time Since I took that basic radical in excess amount, what will it do? It will replace all the replaceable hydrogen ion of acid that you are using. So it will give you Na2SO4, again H2O. Now let us balance it. Na1, Na2. So let us make it 2. Then we have to do H, so here I will use 2 here. So now it's balanced. Twice NaOH plus H2SO4 is giving you Na2SO4 plus twice H2O. So just focus on the salt formed right now, Na2SO4. Does it contain any hydrogen like your previous salt? No, it is not containing any hydrogen. It means it is not going to show you the property of acids. Okay, so this is your normal salt. Now what is the distinction between normal salt and acidic salt? It's very easy. Acidic salt are formed by partial replacement of replaceable hydrogen, and normal salt are formed by by total replacement or complete replacement of replaceable hydrogen ion of a particular acid. Next distinction that you can give is this type of salt will show all the properties of acid since it is acidic salt, and normal salt is not going to show you any property of acids because it is a normal salt. It does not contain any H part. Only this much is the distinction. If you look into the formula, you will easily identify whether it is acidic salt or normal salt by just checking whether H part is there or not. Here H part is there, acidic salt. H part is not there, it's a normal salt. Okay, now let's move on to the third part. It's your basic salt. Now what are basic salts? Simply a basic salt will contain a metal ion, a hydroxide part, and an anion. A metal ion, OH negative, and anion. See, it is containing OH negative part. I hope it is clear. It will behave like a base. Okay. Simply, basic salt are the salt which when you will dissociate in water will give you OH negative ion, and OH negative ion is a property of bases. That is why it is basic salt. It's very easy to understand. Then comes your double salt. Then there are mixed salt. Double salt means which contains two ions. Okay, it will contain two ions. Before that, let me tell you that why I'm talking about a metal ion. Maybe you would be confused that why I'm talking about a metal ion. See, in a simple way, you should understand that in a simple way, metal are positive in nature. Sorry, the ions are having positive charge. So, how to check whether it is acidic or basic? See, by simple trick we can learn it. See, bases are beneficial for your body. Bases are beneficial for your body. It means every positive part will contain basic property like Na positive, Ca2 positive. All these positive parts will be basic in nature. Why? Because bases are good for you. Good means positive. In that way you can remember it. Bases are good for your body. So every positive ion is basic in nature. And acid are bad for your body, negative. So every negative charge species will be acidic in nature, like your Cl negative, O2 negative. Every negative part that you will see, it will be acidic. Just remember, bases are beneficial for your body, means positive for your body. So every positive part is basic in nature. Na2 positive, Na positive, Ca2 positive, Al plus 3 positive, and acid are negative for your body. So every negatively charged species is acidic in nature. In that way you can understand. So here I am talking about a metal ion, positive. So it will be basic. I hope it is clear to you. See, for chemistry you have to learn some tricks. In a trick way you have to remember. Just as I am telling that bases are good for your body, it is not a principle or something like that. Bases are good for your body. You know that your body have some irritation with acids, not with bases. As much bitter you eat, it won't harm you, but more acid content in your body is going to harm you. So in that way we have made a short trick that acid are good for your body, means positive for your body. So every positive Sorry, not acid. Sorry, base. Bases are good for your body. So bases are positive for your body. It means every positive species is basic in nature. Acid are bad for your body. It means negative for your body. So every negatively charged species is acidic in nature. In that way, in short tricks way, you can learn, just as you are learning periodic table using various tricks. In that way, you have to remember other things also in chemistry by using your own tricks. No need to depend on other tricks. You can make your own tricks. Okay. Now let us move on to the basic salt. Then I talked about double salt. Then we talked about mixed salt. Double salt means it will contain two ions. It will contain two ions. So it is containing potassium also and calcium also. It is containing sodium also and calcium also. Suppose in another salt, it is containing Na also and it is containing Ca also. So they are called as double salt. Means double ions will be there. And what is mixed salt? They are the mixture of two types of salt. Like suppose K2SO4 dot Al2SO4 whole thrice dot 24H2O. Now what you are observing here is one salt is this, another salt is this. So two types of salt are there. Mixed salt. Double salt means two types of ions. More ions will be there. Double ions will be there. But mixed salt means different salts are there, but they are combined. Like salt number 1, salt number 2 mixed together. So that is the meaning of mixed salts. I hope it is clear. It's very easy. So what are basic salt? Double salt, I told you, more than one, that is double ions, two ions. Mixed salt means mixture of two types of salt. So what we studied about salt today, after this we will discuss the properties, but what we discussed today is we discussed about acid salts, then we discussed about normal salt, and then we discussed about basic salt. And that also we discussed double salt and mixed salt. Okay, now what are the properties of salts that we are going to discuss according to your syllabus? We won't discuss anything extra. Point to point, according to your syllabus, we are going to discuss. So see salt properties. Property number 1, they are non-volatile. Now what is the meaning of volatile? Volatile means species which need a very low temperature to change their state. They will go into vapor state. Okay. Species which easily, like petrol, if you keep petrol or things like this on your body, if you make them to touch your body, you feel that it's like cool, you feel cool in that particular part of your body. If you keep these petrol and something on your body, you will easily see that after some time they will vanish. Okay, why they get vanished? Because they need that much temperature from your body that they will get vanished. Vanish means they are not disappearing. It means they have changed their state. From liquid, they get transformed to gaseous state at a very low temperature. So those are called as volatile. Now what is non-volatile? Non-volatile means which need high amount of temperature to get transformed from liquid to gaseous or solid to gaseous state. So they are called as non-volatile. I hope you understand. Volatile means low temperature or low boiling point. Simply in the language of physics, you can say that they have very low boiling point or vaporizing point. In a very small point, in a very small temperature, they will change to gaseous state. But non-volatile means which won't easily change to gaseous state. Suppose, let us take an example. In one hand you are keeping petrol and on the other hand you are keeping a small piece of wood. So petrol is volatile. After some time it will vanish by taking heat from your body. Why you are feeling cool? Because some part of your body, the heat content of your body has been transferred to that petrol or any other volatile thing to get it changed to gaseous state. So actually what is happening? Some heat from your body is losing. Since some heat from your body is losing, that's why you are feeling that you are feeling cool. That cooling sensation is there. Okay, and already you studied in physics that evaporation produces cooling. So since something is evaporating but taking heat from your body, so it will give you cooling sensation because your body's temperature is getting down or your heat content of your body is getting down. Okay, so they have very low boiling point, so they are volatile. Which have a high boiling point, they are non-volatile. So salt comes in that category, that they are non-volatile in nature. Second part is they are electrovalent compound. Now what is electrovalent? Electrovalent compound simply means transfer, formed by transfer of electron. One is sharing of electron that is covalent bonding. One is transfer of electron, that is electrovalent bonding. Third type of bonding is dative bond or coordinate bond, where suppose it's X and Y, so only one is transferring electron. Here Y is not giving its electron to X for sharing, or it is not transferring. Only X is doing the bonding here. The two electrons that is used for bonding between X and Y are provided by X alone. So those type of bondings are called as coordinate bonding. For example, in H3O positive, H2O adds a proton. Now see, a proton does not have any electron. A proton does not have any electron. It means this part, the lone pair of water, is being used here for the bonding, so it gives you this type of structure. Okay, so this is known as coordinate bonding. So salt go for electrovalent bonding, means transfer of electrons take place in salt formation. Now another important part, another important property of salt is deliquescent and your efflorescence nature. Efflorescence already you have studied. Efflorescence and deliquescence. Very easy part. What is efflorescence? Efflorescence means when a material, let us talk about a material first, then we'll talk about salt. Efflorescence means a material which loses its loose water combination and change into a powdered form. That is called as efflorescence. It will lose its water, like copper sulfate .5s2. Give it some heat, it will change to anhydrous form with the liberation of its loose combination. The water which will lose in a loose combination with this copper sulfate on exposure to heat, or suppose we are providing heat, then on absorbing that heat, it will lose that, or it will leave that loose combination. So they are called as efflorescence material. And what is efflorescence salt? Means the salts like copper sulfate, salt which when provided heat will lose its loose combination of water. That loose part is gone now. That loose part is gone now, and it has changed to anhydrous. Remember that dry part in chemistry is called as anhydrous, and this is called as hydrated. So I can call it as hydrated copper sulfate. Here I can call it as anhydrous copper sulfate. So this is the meaning of efflorescence. And efflorescent salt means salt which on exposure to heat leaves that loose combination of water and change to powdered form, that is anhydrous form. Now deliquescence. Deliquescence is very simple. Deliquescence means here the salt is going to absorb moisture. Salt will absorb moisture and change into solution form. Salt when exposed to moisture will add that moisture to itself and will change into solution form. They are called as deliquescent salt. They are called as deliquescent salt. Normally salt that you're watching at your home, observing at your home, when they are exposed to the atmosphere, they absorb some moisture from the atmosphere and change into solution form. You will observe that they change to liquid form. So those type of salt are called as deliquescent salt. So I hope it is clear what is efflorescent salt and what are deliquescent salt. Deliquescence means deliquescence material, and here we are talking about salt, so we will call it as deliquescent salt. Deliquescent salt. And in the same way, efflorescent salts. Efflorescent salt are the salts which loses their loose combination of water and change to powdered form or anhydrous form. Deliquescent salt are those salts which when exposed to the atmosphere will absorb moisture and will change to that solution form. Okay, so I hope the properties are clear. Non-volatile nature, electrovalent bonding, deliquescent nature, or efflorescence nature. They may be efflorescence or they may be deliquescent. It cannot be that salt is both deliquescent and efflorescent. Okay, either it will be efflorescent type or it will be deliquescent type. So this all video was about your salts. Try to remember what we discussed in this video: acidic salt, basic salt, normal salt, mixed salt, double salt, properties of salts, efflorescent nature, deliquescent nature, electrovalent bonding is found in salts. Okay, so all these things we discussed in this particular video. So I hope most of the doubts regarding salt will be cleared by watching this video. So keep growing, keep studying. We'll meet you in the next video. Thank you.